Welcome back to Basic Electronics video lecture. Now in this we will discuss the Unit 3 concepts. In Unit 3 is divided into two parts. The first part is feedback concepts and second part is oscillators. Now in a feedback concept, before going to discuss about the feedback concepts, now let discuss the different types of amplifiers. Now here total 4 different types of amplifiers are there. One is a voltage amplifier, current amplifier, transconductance and transresistance. These are the 4 types of amplifiers. So we will see the equivalent diagram for these amplifiers. Now this is the voltage amplifier where the input and output both are the voltage signals. Now here, before going to discuss about this equivalent diagram, now let me explain the diagram for the voltage source and current source. Now if I take this as a voltage source, now this is a voltage source, this is the ideal voltage source. So it is not having any resistance. Now if I take the practical voltage source, always voltage source is having the series resistor. Now if this series resistor is how much lesser the value, Rs is equal to 0. If how much lesser the series resistor value, it almost act like a ideal voltage source. So this is the equivalent symbol for the voltage source. Similarly for current source. Now this is the ideal current source which is not having any resistor. Now for this practical current source is always the current source is having the parallel resistor, that too very high value. If this resistor value is equal to infinite, this current source acts like a practical current source, acts like a ideal current source. Now in a voltage source, if the internal resistance is how much lesser, then that much better the source. Coming to the current source, how much higher, if the value is parallel resistor value is how much higher, then that is the best current source. Now these are the two equivalent diagrams for the voltage source and current source. Now if we have an idea, then it will be very easy to discuss these equivalent diagrams. Now this is the voltage amplifier. Now in this box, this is the equivalent diagram for the amplifier. Now here for this amplifier, voltage from the sig source we are applying this voltage, and here with the load we are taking the output. Now this is an amplifier circuit. If we are taking the voltage, then the output side we have to draw the equivalent diagram as a voltage source in series with the resistor. If output we are taking the current, then here we have to draw the current source in parallel with the internal resistor. This is the amplifier internal. R0 is the amplifier output resistance, Ra is the amplifier input resistance. Now this is the equivalent diagram. This is an amplifier. Now for that what we are applying the voltage source, and here across the resistor we are taking the voltage. So this is the voltage amplifier. Now for this the gain A is equal to, or we can represent V. Why? Because both are voltages, we can take the suffix V, indicates the voltage gain. This is nothing but V0 divided by Vs. Input we are applying the S and output is V0. From this V0 is equal to AV into Vs. Now this is the output for this voltage amplifier. Now here in this case, if Ra is how much higher, then that much amplifier receives the input signal and amplifies, and after the amplification it has to transfer the signal to the load. It should not drop any voltage. The complete signal should supply to the load, means what? Here the R0 value should be very less. Now here if you see, Ra should be greater and R0 should be lesser than the RL value. Then at that time it is the best voltage amplifier, it will give the best gain. So this is about the voltage amplifier. Now next one is current amplifier. Next one is current amplifier. In this case we are applying input side, it is a current signal, and output also we are taking the current. Now already in the amplifier circuit already I have explained that if we are taking the current at the output, then we have to draw the current source here. If we are taking current source, then in parallel with the resistor we have to take. So this is R0 is the amplifier output resistance, and Ra is the input side. For both, for any amplifier, input side is only resistor we have to draw, but output side, whether voltage we are taking or current we are taking, what parameter we are taking, depending upon that we have to draw the voltage source or current source. If we are taking voltage, then draw the voltage source in series with resistor. If we are taking the output parameter as current, then draw the current source in parallel with the resistor. Now this R0 is an amplifier, this is an amplifier, complete amplifier, this is the Rin is an amplifier input resistance, and here it is a output resistance. If you are applying the current source, then how much we are applying the current, complete current should flow through this resistor means what? Here RS value should be greater than and RA value should be less. Then only the amplifier takes the complete signal. Now here if the value is now here complete current, whatever the current we are applying, everything should flow here means what? This value should be much higher, or how much higher the RS value, that much better the amplifier takes the input signal. That's why here if you see RA should be lesser for the current amplifier, and similarly after the amplification the complete current should go to the RL. For that what again? R0 value should be higher, thereby what? It will not drop any current, current will not flow through the R0, and the maximum current or complete current should flow through the RL. So this is in the case of current amplifier. In the case of voltage amplifier, how the input resistance should be? Input resistance should be high and output resistance should be low. Now in the case of current amplifier, how the input resistance should be? Input resistance should be low and output resistance should be high. Now next remaining two are the transconductance and trans resistance. Next, so transconductance means what? Output is a current and input is a voltage. So output is a current, that's why output side in the amplifier, output side we have to take the current source in parallel with the resistor. Now here input side we are applying the voltage source. So the complete voltage should apply to the amplifier means what? Here this resistor value should be very, very high. If this resistor value is high, then it will take all the voltage. So always voltage is directly proportional to the resistance. If how much higher the resistor value, that much more voltage will be dropped by the amplifier, and it will amplify the signal, and it will and current is given at the load. So maximum current should flow through the load means what? Here R0 value should be very, very high. Now in this case both the value R0 and RI, both the value should be very, very high. This is about the transconductance amplifier. Similarly next one is a trans resistance, that is a reciprocal, opposite to this transconductance. So this is the opposite to the transconductance. Now here input we are applying Is and output we are taking the voltage. So output side we are taking voltage, that's why here we have taken the voltage source in series with the resistor. And how the resistor, because whatever the current we are applying should flow through this means what? Here whatever the current we are applying should flow through the input resistance means what? Input resistance should be very, very low. Now this should be very, very low. And after the amplification, complete voltage source, voltage signal should be applied to the output, means it should not drop any value means what? Here also the value should be very, very low. So here both the RA and R0 value should be very low. This is the this is about the amplifiers. Now here the brief analysis is given. So these are the four amplifiers, and what is the input parameter and what is the output parameter, and how the resistance, input resistance and how the output resistance. Now this information is required for the feedback concepts. Now we will look into the feedback. Now what is feedback? Feedback is nothing but a part of the output is fed back to the input is called the feedback. Now a portion of output signal is taken and again applied at the input, that is called the feedback. Here there are two types of feedbacks are there. One is a positive feedback and another one is a negative feedback. What is positive feedback? When we are applying, taking the output and applying at the input, that signal should be in phase with the input signal. Nothing but that feedback signal is added with the input signal, then that is the positive feedback. And a negative feedback means whatever the output we are taking, sample of output we have taken, when we are applying at the input, that is subtracted from the input signal, or the phase is 180 degrees out of phase with the input signal, then that is called the negative feedback. So these are the two different types of feedbacks. Now what is the need of the feedback, especially negative feedback? What is the need of negative feedback? Means if in the previous lectures we have discussed that amplifier means when we give the small signal, amplifier amplifies the signal strength and it gives the large signal at the output. Now if this is an amplifier, if I am applying a small signal over here, at the output we get the largest signal. Now along with this information, now what is input signal? Input signal is nothing but some information. Along with this information, if any noise is added, then that noise also amplified by the amplifier, and the noise also will be available at the output. If that should not be happened, means what? We need to apply the negative feedback. With that negative feedback, what happens? It will eliminate the noise, or otherwise we can say that it will not amplify the noise very high. Now, like how much information signal is amplified, that much noise is not amplified with the negative feedback. That is the one reason. So here we can reduce the distortion and we can reduce the noise. So what is the difference between noise and distortion? Distortion means what? Here if my signal is this, and if now in the last lecture I have explained that in a CE amplifier I have explained that this is a load line, and here we are getting the waveform like this. Now this is my range. Now this is the maximum range. Now within this range I can amplify like this. But if my signal is going beyond this range, then I will get the waveform like this. Almost it look like a square wave, not the sine wave. Means what? So these peaks are now clipped off. These peaks are clipped off means what? This is called the distortion. So losing information is nothing but a distortion. What is noise? Extra information is added to the original signal is called the noise. So that both noise and distortion will be reduced by using this negative feedback. So that's why we are using this negative feedback. Now we will see that how it is going to reduce this and what happens to the gain and all we will see